Okay, Math 3 notes. I'll go ahead and open your table of contents and add exponential functions to it. Put whatever page you need. Again, pause it at any point if you need to. So definition is f of x is equal to a times b to the x. It's called an exponential function because your variable is your exponent. There are some rules that you got to follow. B has to be positive. So it's got to be greater than 0. So B has to be positive. And your A cannot be equal to 0. So A needs to be a different number than 0. Because if A was 0, then everything would be 0. So if B is greater than 1, so if what your scale factor, what you're multiplying by over and over and over again is greater than 1, you're going to have a growth problem. If your B is less than 1, so a number between 0 and 1, so a decimal or a fraction that's less than 1, then it's going to be decay. A ends up being your y-intercept, which will always be 0a. And that's because anytime you plug in 0, this part will always be 1. So it'll be a times 1. So we're first going to, our first example is going to be graphing f of x is equal to 4 times 2 to the x. Your a here is 4, which means our y-intercept is going to be 0, 4. Our b in this problem is 2, which means this should be a growth function. So to be able to graph this, we're going to create a t-chart with some negatives and some positives. I'm going to start with the positives. We're also going to talk about domain, range, and an asymptote. So I'm going to plug in 0. 0 is the easiest number to plug in. This is going to be 4 times 2 to the 0. Anything to the 0 power is 1. So this is 4 times 1, which is 4. Then I'm going to plug in 1. So it's going to be 4 times 2 to the first. 2 to the first is 2 times 4 is 8. Then 4 times 2 squared. Exponents first. 2 squared is 4. 4 times 4 is 16. 4 times 2 to the third is 4 times 8, which is 32. 4 times 2 to the negative 1. Using our rules of exponents, that means this is 4 times 1 over 2, which is 2. This is going to be 4 times 2 to the negative 2, which is 4 times 1 over 2 squared. 2 squared is 4. So 4 times 1/4 is 1. The next one is going to be 4 times 2 to the negative 3, which is 4 times 1 over 2 to the negative 3 is 8. 2 to the third, which is going to be 1/2. You might also recognize that, whoops, I don't know why I wrote 1/4. My brain broke. Let's fix that. 1/2. You might also recognize that going forwards, 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's because we're multiplying by 2 over and over again. If you go backwards, divide by 2, 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 divide by 2. Okay, so divide by 2 again, divide by 2. So if we graph these points, negative 3, 1/2, negative 2, 1, negative 1, 2, 0, 4, 1, 8. Okay, this is what this graph is going to look like. Now what happens as we get more negative? We're just going to continue dividing by 2. If we follow the pattern of dividing by 2, it's just going to get smaller and smaller and smaller, and it's actually never going to touch 0. So that's what that graph looks like. Our domain is, we plugged in negatives, we plugged in positives. We could have also plugged in any decimals. We're not going to because why waste our time? So our domain is all real numbers. So I'm going to write it like that. I'm okay with you also writing all real numbers. Our range, notice none of our answers, and because we're going to keep dividing by 2, these just will get smaller. They will never actually equal 0. So none of our answers will be negative or ever equal to 0. So our range is y is greater than 0. If you want to put that like this, you can say 0 to infinity with parentheses. Our asymptote. Our asymptote is a line that a graph approaches but never crosses. Our asymptote for this problem would be the x-axis. The equation of the x-axis is y is equal to 0. And I will put that as the x-axis, because your y will never be equal to 0. It'll get very close to 0, but will never equal 0. So as you can see, this is a growth. It's growing over time. Okay, the next problem we're going to do is g of x is equal to 1/2 x. Our a value here is an invisible 1 in front. So our a value is 1, which means our y-intercept will be 0, 1. Our b value is 1/2, which means this is going to be a decay, because our b is less than 1. Okay, so the numbers we're going to plug in are -2. So what that means is 1/2 to the -2. Because it's negative, we flip the fraction and make it positive. So that's 2 over 1, or just 2 squared. So that's going to be 4. 1/2 to the -1, because it's negative, we're going to flip it, and it's going to become 2 over 1 to the first, which is just 2. Anything to the 0 power is 1. 1/2 to the first is 1/2. 1/2 to the second, 1/2 squared means 1/2 times 1/2, which is 1/4. 1/2 to the third just means 1/2 times 1/2 times 1/2, which is 1 over 8. So if we're going to graph this, -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4, 3, 1/8. So notice those points are just getting closer and closer to 0. But it will never actually turn into it. So the domain, again, for this one is all the real numbers. Your range is the same. There are no negatives because it's just going to keep dividing by 2 or multiplying by 1/2. So our range is y is greater than 0. Our asymptote for this one, again, is y is equal to 0. And that are graphing our exponential functions.